Good morning, children. We are starting a new chapter today, and the chapter we are starting over here is surface chemistry. We are starting the chapter surface chemistry. In this chapter, what we see that the chapter starts with the topic adsorption. Now, the question is, what is adsorption? Now the question is, what do you mean by the term adsorption? First of all, we should know that adsorption is a surface phenomena according to which we know that it is a method by which there is the accumulation of molecular species at the surface of a solid or liquid rather than its bulk. And that's why adsorption is called the accumulation of molecular species at the surface rather than in the bulk of the solid or liquid is termed as adsorption. Now, next important thing that it is a surface phenomena, and according to the surface phenomena, the concentration of the adsorbate increases only at the surface of the adsorbent. Okay, now we should encounter two other terms. The first term is adsorbate. Now, what is a adsorbate? Adsorbate is the substance which is been absorbed on the surface of another substance. And what is adsorbent? It is the process of removing of the adsorbed substance from the surface when it is adsorbed. Okay, so just try to understand two factors are there. One is adsorbate, other is adsorbent. What is adsorbate? Adsorbate means actually that substance. Adsorbate means that substance which is actually been absorbed at the surface of another substance, that is called as adsorbate. Okay, now the next substance we have is adsorbent. What is adsorbent? Adsorbent is the substance which is present in the bulk on the surface of which adsorption takes place. Suppose I tell you that we have spilled some water and I have put a thick piece of sponge. Now the piece of sponge which is in contact with water, its upper surface or the surface that is in contact with the water, that will absorb it. So in that case, what is the adsorbate? The water which is adsorbed is called the adsorbate, and the thick piece of sponge is called the adsorbent. Okay, so the substance which is adsorbed is called the adsorbate, and the substance on which adsorption takes place is called as adsorbent. After that, we have the next topic, that is called desorption. What is desorption? It is the process of removing the adsorbed substance from the surface of which it is been absorbed. It is the process of removal of the adsorbed substance from the surface is called as desorption. Now another term we have is called sorption. What is sorption? If both adsorption and absorption takes place together, then it is called as sorption. Okay, so if I want to tell you what is adsorption, we have come across that it is a phenomenon in which the accumulation of the molecular species takes place at the surface rather than in the bulk of the solid or liquid is termed as adsorption. Okay, and it is actually a surface phenomena. And the next thing is that the concentration of the adsorbate increases only at the surface of the adsorbent. Okay, now next topic we have over here is absorption. What is absorption? Absorption is actually a phenomena. Absorption is actually a phenomena in which we see a substance is uniformly distributed throughout the bulk of that substance. So here we see the next term we are having is absorption. What is absorption? Absorption is actually a phenomenon in that we see that a specific substance gets actually, see, this phenomena is absorption. What is absorption? Absorption is the phenomena in which a substance is uniformly distributed throughout the bulk of the solid. So it is called a bulk phenomenon. Why is it called a bulk phenomena? Because the whole process takes place throughout the substance. And next point is the concentration is uniform throughout the bulk of the solid. That is, the concentration is uniform throughout the bulk of the solid. Now if I ask you what is the basic difference between adsorption and absorption, you should understand that adsorption involves unequal distribution of the molecular species in the bulk and at the surface, On the other hand, absorption means the uniform distribution. Absorption means actually uniform distribution of the molecular species throughout the bulk. Next, adsorption is a rapid process in the beginning, but it slows down at the end. So just remember, adsorption is a very much rapid process and it is very fast in the beginning, but as the process proceeds, what happens? It actually becomes much more slow. So the process of adsorption takes place at the beginning, but gradually as we proceed later on, what happens? The process becomes slow. That is one important basic difference. The third difference is that adsorption, as it is been told, is a surface phenomenon. On the other hand, absorption is a bulk phenomena. Bulk phenomena means it takes place throughout the whole surface. Okay. So these are the two basic differences between adsorption as well as absorption. Okay. Now another new term here we have is sorption. What is called sorption? Sorption is a process when both adsorption and absorption takes place simultaneously. What is the meaning of simultaneously? That is taking place together. That is called as sorption. Okay. So in some certain substances, what is happening? Both the adsorption and absorption is taking place simultaneously. That is actually called as sorption. Okay, is this part now clear? Now next topic we are having is enthalpy or heat of absorption. What is enthalpy or heat of absorption? Enthalpy or heat of absorption means actually, since the adsorption occurs with the release in energy, that is it is exothermic in nature. So just remember, whenever adsorption or absorption taking place, both these cases it is actually exothermic process in which high amount of heat is being released. The enthalpy change for the absorption of 1 mole of adsorbate on the surface of an absorbent is called enthalpy or heat of adsorption. What is called enthalpy or heat of adsorption? It is the amount of energy or the heat that is needed for the reaction to complete is called as enthalpy of adsorption or enthalpy of absorption. Okay. Now one important thing that should very much clear to us, that whenever the process of adsorption takes place, high amount of heat is being released. Because of the heat that is being released, we can say that in this process actually huge amount of heat that is being released is called enthalpy of adsorption, or it is called the heat of adsorption. Now the next topic we are having is types of adsorption. What are the different types of adsorption? There are two types of adsorption. One is called physical adsorption, other is called the chemical adsorption. Physical adsorption is called as physiosorption. Now in the process of physiosorption, what we have, this is called physical adsorption. So if the adsorbate is held on the surface of the adsorbent by the weak van der Waals forces, it is called as physical adsorption or physiosorption. So just remember, if the adsorption process takes place by simple weak van der Waals forces, then this is called as physical adsorption. Okay, it is actually non-specific in nature, it is reversible in nature, and the amount of gas depends upon the nature of the gas. Okay, so this type of process is called physical adsorption. For example, here you can see that the amount of gas deposited depends upon the nature of the gas. Easily liquefiable gases like ammonia, carbon dioxide gas adsorb to a greater extent than hydrogen and helium. Higher is the critical temperature of the gas, more will be the extent of adsorption. The extent of adsorption increases with the increase in surface area. That is the porous finely divided metals are good absorbent. There are the weak van der Waals forces of attraction between the adsorbate and the adsorbent. Next important point, you should know that it has actually low enthalpy of adsorption. Okay, the enthalpy of adsorption in this case is much low. Enthalpy adsorption in this case is much low. As the enthalpy of adsorption is much low, now what we know that it is as much as 20 to 40 kilojoule per mole, and also the temperature is low for the favorable of physical adsorption. No appreciable activation energy is needed, and it forms molecular layers. It forms multi-molecular layer for the process of adsorption to take place. So these are the basic points. Before I move to the next point, I would like to summarize what are the basic points for physical adsorption. In the process of physical adsorption, the adsorbate is held on the surface of adsorbed by the weak van der Waals forces. That is the important factor. Next is that it is non-specific. Then it is reversible. Amount of gas depends upon the nature of the gas, which is easily liquefiable. The extent of adsorption increases with the increase in surface area. They are because of weak van der Waals forces. And the next important thing is that it has low enthalpy of adsorption. That is, low temperature is favorable for the process to proceed. Next, there is no appreciable activation of energy is needed, and it forms multi-molecular layer. These are the simple characteristics of the process of physical adsorption. After that, we are going to discuss about chemical adsorption. Or that is called as chemisorption. So we are now going to discuss about chemical adsorption, or that is called as chemisorption. We are going to discuss about chemical adsorption, or that is called as chemisorption. In the chemisorption process, first of all, see, it is the force that holding the adsorbent, and the adsorbate in chemical adsorption is a very strong force. Okay, and next important property is that just try to understand, it is a highly specific process, and it is irreversible in nature. The amount of gas adsorbed is not related to the critical temperature, and it also increases with the increase in surface area. It has an enthalpy of heat of adsorption. See, in this case, enthalpy is 180 to 240. In case of physical adsorption, enthalpy was only 20 to 40 kilojoule per mole, but here it is 180 to that of 240 kilojoule per mole. It is actually 180 to 240 kilojoule per mole. That is one of the important characteristic. Another is that high temperature is favorable for this process. Next, high activation energy is sometimes needed, and next, it also forms unimolecular layer. So if I now discuss what is the basic difference between physical adsorption and chemical absorption, which is a commonly asked question, you should try to answer it in a tabulation. When I tabulate it for physical adsorption, you should mention that it is the attractive forces between the adsorbate and the absorbent, which is a weak van der Waals forces. But in this case, the amount of force is a type of strong chemical bond. Next part, we should know that in this process, one important factor is that the amount of bond energy in this case is 20 to 40 kilojoule, but in this case it is 180 to 240 kilojoule. Next important property is that it requires very low number of activation energy. See, the activation energy is very low. In this case, we have a high activation energy. Next is low temperature is favorable. Here it is high temperature is favorable for this process to proceed. That is the third difference. After that, it is a reversible process. In this case, it is a irreversible process. Okay. Next important is that it is related to the case of liquefaction of gases. I have told you easily liquefiable gases they actually show. In this case, it is actually related to those type of substances which generally is not related to liquefaction of gases. After that, it usually forms multi-molecular layer. In this case, it forms a unimolecular layer. In this case, it forms multi-molecular layer. In this case, it forms unimolecular layer. So these are the basic difference between our physical adsorption as well as chemical adsorption. Okay, is this part now clear? After that, we are going to discuss the next factor, that is factors affecting the physical adsorption. What are the factors that affect the process of adsorption of gases on solid? The first factor is nature of adsorbate. What is the nature of the adsorbate? Physical adsorption is non-specific in nature, and therefore every gas get adsorbed on the surface of any solid or liquid. You could see to a much lesser or greater extent. However, the easily liquefiable gases like ammonia, HCl, carbon dioxide, etc., which have higher critical temperature are adsorbed to a greater extent, whereas hydrogen, nitrogen, oxygen are adsorbed to a lesser extent. The chemical adsorption being highly specific, therefore a gas gets adsorbed on the specific solid and enters into chemical combination with it. These are the factors for the nature of adsorption. One of the important factor. After that, see next factor, we have nature of the adsorbent. So nature of the adsorbent controls the process of adsorption. Nature of adsorbent also controls the process of adsorption. See, the activated carbon, metal oxide like aluminum oxide, silica gel and clay are commonly used adsorbent. They have high specific adsorption properties depending on the number of pores. Next important factor we have over here is the specific nature of the adsorbate. What is the specific nature of the adsorbate? See, here we have the specific nature of the adsorbent. Now, greater the specific area of to move higher will be the extent of adsorption. That is why pores or fine divided forms of adsorbent are having larger quantity of adsorbate. Okay, and hence the pores should be large enough to show the process of gaseous molecule to enter. Now, last factor is the pressure of the gas. Physical adsorption increases with the increase in pressure. Larger the pressure, larger is the increase in the number of physical adsorption increases with increase in pressure. Physical adsorption increases with the increase in pressure. So these are some of the factors. So if I just summarize what factors affect the adsorption of gases on solid, the factors over here is the first factor we know is the nature of the adsorbate. Second is the nature of the adsorbent. Then is the specific area of the adsorbent, and last is the pressure of the gas. So as this goes on changing, the process of adsorption also changes. As it goes on changing, the process of adsorption also changes. In this way, we can say that in this part of the chapter, we have discussed about some of the important definition, and the important definitions that we have discussed in this part of the chapter is adsorption, absorption. Then we have discussed about what is called desorption, what is called sorption, what is called enthalpy of heat of absorption. Then we have discussed two types of adsorptions are there: physical adsorption, chemical adsorption. After that, we have discussed the properties of physical adsorption. Then we have discussed the important properties of chemical adsorption. How does physical adsorption, chemical adsorption varies? That also we have discussed. Now the basic differences also we have discussed, that what is the basic difference between that of physical adsorption and that of a chemical adsorption. All these factors we have discussed. After that, we have discussed about the important factors which actually helps, the factors that affect the process of adsorption of gases of solids. The nature of the adsorbate we have discussed. Now the factors on which adsorption depends are nature of the adsorbate. Then we have discussed about nature of the adsorbent, specific area, and the pressure on which it depends. Okay, so that was actually introduction to the first part of the chapter. That was simply introduction to the first part of the chapter. Here we have discussed certain basic terms, important terms, and the basic difference between physical adsorption and that of chemical adsorption. Okay children, that was all for the day. Thank you.